or unluckily Sputnik worked, and we are still stuck with the Sputnik architecture when it comes to the way we design satellites, although it's been 70 years. Meaning whenever we get a customer, we don't manufacture any hardware in-house. Probably we are the only satellite company that doesn't manufacture any hardware in-house but sell satellites. By this way, we get a lot of flexibility. We can actually reduce a lot of customization costs. Having a software as a core to our architecture, we can start having a lot of very advanced functionalities on board our satellite way before you even build the satellite. Therefore, we are always not one step but 10 steps ahead of the market. We are at the forefront of really leading that space revolution.
Hello and welcome to WGIC, the World Geospatial Industry Council. Our guest today is Sethu Saveda Suvanam, founder and CEO of ReOrbit, a company that's redefining space technology. Sethu, welcome to WGIC. Thank you for taking this time for this conversation.
Thanks, Bhanu. Thanks for inviting me.
My first question, Sethu, because I was going through your website and I was very fascinated that you talk about the limitations of the current space technology doing things the Apollo way.
So what are the limitations of the current space technology or the hardware first way? How can software first satellites bring greater flexibility, connectivity and autonomy?
Yeah, just looking at how space industry has been evolving since the launch of the first satellite, almost till the launch of the satellite that would have been launched today. The way the satellites are built are very similar. They're very hardware oriented, meaning that today when you buy satellites, you are always thinking about the hardware inside it, whereas the software, which brings a lot of value that we are seeing on the other industrial verticals, is it's never spoken. In fact, no one even sort of thinks about software until the hardware components are put together in the space industry today. Whereas if you look at all the industrial verticals that are similar to space industry, like computers, mobiles, automotive, aeroplanes today, aviation, they've all started that way. Like all these industries started with big hardware pieces, right? Like when you, for instance, take the computer, IBM mainframe computer, like 40 years ago, it was probably a size of a room or something with a lot of mechanical parts and almost no software intelligence on it. But today, the premiums you pay on these products is just for the software intelligence, and that's what we are now basically trying to get into the satellite industry. Basically, we are not in a way reinventing anything. We are just reusing what's there. All those architectures, all those design philosophies that's been tested on other industries is what we are implementing on the space industry, on the satellite industry, by building satellites as a software-enabled or software-first architectures, meaning that we have now built a core software framework as an architecture to our backbone to our architecture. And then we treat hardware as a commodity, meaning whenever we get a customer, we don't manufacture any hardware in-house. Probably we are the only satellite company that doesn't manufacture any hardware in-house but sell satellites. We go to the market once we have the requirements, procure the best-in-class hardware that is very well tested, a lot of heritage, and then we glue that around our software core or the software architecture. By this way, we get a lot of flexibility. We can actually reduce a lot of customization costs. Today, anytime you build satellite, there's a huge customization cost, increasing the price dramatically. So we reduce that. And even more importantly, having a software as a core to our architecture, we can start having a lot of very advanced functionalities on board our satellite way before you even build the satellite. Therefore, we are always not one step but 10 steps ahead of the market.
So can you help me understand how this technology can make the space more affordable and sustainable?
Yeah. Okay. So as I said, again, going back, so one, today, when you're starting with hardware, and if you look at generally, I would say probably almost 99% of the satellite manufacturers, they manufacture the hardware in-house, everything, or largely. So there is two restrictions with that, right? Like one, you're putting a huge amount of investment into developing those hardware components, which at the end of the day, you're not selling those hardwares, but you're selling a system. So at the end of the day, all that cost is actually put on the customer.
Yeah.
And number two, when you are selling a satellite, you have to be a bit more flexible because you are actually working with different kinds of customers on different applications. And now when you are actually having a very rigid fixed box of hardware, because you are manufacturing it or everything by yourself, you are always limited by what these hardware that in what you have developed in house. So either they're left with two choices, right? Either they address a very limited market that is set by their hardware limitation, or they can basically build new hardware on a go from customer to customer, which is practically impossible because you're investing huge amount of money into those hardware developments. So but now doing the way we do, and this is again nothing new. If you now open a hood of a laptop, none of the components within a laptop actually is manufactured by the laptop manufacturer. Like if you have a Lenovo computer, none of the hardware is from Lenovo. Everything is coming externally. What Lenovo is doing is just leveraging those technologies that someone else is developing on the hardware side and gluing all that on a software based architecture, and it's the same. So this way you get extremely high reduction in cost because we don't invest in huge NREs, we don't invest in huge development cycles, so on and so forth. And also our teams are very lean because we are very system oriented, very software oriented, so we could have a very lean teams as well. So that reflects on the cost. And in terms of sustainability, so I would say no satellite manufacturer can claim they're sustainable, because at the end of the day you're manufacturing satellites to launch. So claiming sustainable would be a very ironical thing to say as a satellite manufacturer. But what we say is we are not sustainable, but we are actually trying to optimize the resources in a much more better way, so that you could at least sort of reuse the systems that are already in space. For instance, because of our software-based architecture, it enables us to design satellites like flying routers, meaning you launch one, you launch another, they can talk with each other, they can exchange data with each other, and resources also with each other. So now you have satellite A, which is probably partially damaged. In today's day and age, what happens is if you have a satellite that's partially damaged, you're just dumping that satellite, although core of these functionalities are performing. Whereas when you have a satellite architecture that can exchange resources between satellites the way that we build, you could, although your satellites are partially damaged, you could still connect with a nearby satellite and still reuse those stuff.
So this would certainly bring down the turnaround time as well, right? The time to build and launch the satellites.
Yeah, exactly. Yeah, because we don't build anything in-house, and then we basically leverage on the suppliers. Exactly. So the turnaround time is also significantly reduced.
Okay, fantastic. So when it comes to the trade-offs, do you see any trade-offs in this approach vis-a-vis the conventional approach to building satellites and launching satellites?
Yes, I mean the biggest trade-off is the mindset. At the end of the day, space industry is so conventional that probably all your listeners who are from the industry can relate to. The industry works with the principle: if something works, never change, and that's why, luckily or unluckily, Sputnik worked, and we are still stuck with the Sputnik architecture when it comes to the way we design satellites, although it's been 70 years. And change, bringing a new way of building satellites that's been or challenging a 70-year-old kind of a mindset is definitely a big trade-off or a challenge that we have to fight, and that's been like our sort of initial struggles to basically convince the industry, look, there is another way to build satellites which could be very efficient. But today, after four and a half years, the industry has really recognized that, and a lot of the people are actually talking about what we've been talking in 2019 when these kind of concepts didn't even exist.
So on that note, would you like to share any of your recent and successful implementations and how that is benefiting the customers?
Yeah, for instance, now we are working with an ESA, we have an ESA, European Space Agency project called UCO, where we are launching a satellite in April 2025 that will demonstrate inter-satellite links, but also the software enabled architecture. So where we have, like in this project, we have actually first written a software, the whole software code, without selecting any hardware. and then we have actually sort of selected the hardware after the whole software core has been written, so to test like how it works. But also apart from that, we have developed a lot of functional libraries within the software, again way before we have the hardware selected, that directly interacts with the hardware. So for instance, the mission will demonstrate distributed architectures, meaning inter-satellite links, space to space, space to ground. We'll also demonstrate autonomous FTIR and autonomous station keeping and autonomous operations, if I have to put it. So there are a lot of things that we demonstrate is largely dependent on hardware, but the way the architecture was written is completely new. So it'll be a nice nice demonstration of what we've been saying.
Okay, so moving a little further into the space industry right now, the global new space or the commercial space sector is witnessing a rapid growth and is poised to expand near double-digit rate in the next few years, right? So what are your views on this new paradigms and directions the space sector is taking to serve space for Earth economy?
Yeah. I mean, this is, I would say it's a very welcome, maybe it's also been a bit selfish. So it's a very welcome move that it's growing the rate. It's growing because I work in this industry. But also I think it's overall, this is a trend, industrial trend that we've been seeing, not just now, way since last 2000 years, right? Like you started with horses, then you have the carts, then you had the industrial revolution. Now, you have the computer revolution. 2007, we saw the mobile revolution with the iPhones. Now we are actually going to the space revolution. So I think it's a trend that's bound to happen. And at least for me, I can say we are quite lucky as a company that we actually came at the time where it was just about to happen, and we were actually working on those big problems that the industry had to solve if this happens, and we started solving those few years before this thing started, right? Like, so in that sense, I think today we are at the forefront of really leading that space revolution, and this is a trend that will definitely continue, as you said. And what will be more exciting and interesting is what would be the next revolution that will come after this, and where would this space revolution take us, and that's an exciting thing to witness and see where we'll end up.
Going through your website and was very fascinated with this product called Gluon EO. So I see it has a AI analytics on board. And how does this function and benefit the users downstream? Can you help us understand?
Yes. So basically, Gluon EO is what we are demonstrating with the UCO project, just to reference to that. So I can give you one practical example to sort of show how it benefits, right? Like, so today, I mean, the core of the Earth observation users are defense and security. I mean, that's the reality. And one of the biggest problems, let's say, these users have is the time to react, or the time it takes for them to spot something and then to react. So the reaction time is a very big bottleneck. Why? Let's say you're sitting in Chennai or Visakhapatnam or somewhere along the coastal line, and then there is some activities on the deep shores that India doesn't want to happen. And today what happens is the only way you could map these is through satellites, because there is no other way to map anything that's happening in deep shores. So today, the time it takes to take a picture of this particular activity, to send it to the ground segment, then send it to a base station, then send it to the armed forces, and then to send it to the coastal guard, it's probably a day, sometimes 2 days, or even more. And by the time the Coast Guard gets this information, probably the ones that are doing what they're doing there have already done and left. So now let's say with ReOrbit satellites, how does it change? So if you have a distributed architecture, so you could now start running a lot of advanced data processing algorithms, one on board, because now it's like this distributed computing, right? At the end of the day, a satellite is a flying computer with a solar cells and a propulsion. So once you can exchange information and data, and you have the ability to sort of run those algorithms distributedly, so the moment you take a picture, you're splitting the data, exchanging it to all the satellites that are connected within that loop. You process the data, and then you have an ISL capability, optical intersat link. So you're directly sending it to a GEO or a MEO satellite sitting high up that's directly connected to the Coast Guard. So you're sending a message to the Coast Guard directly. Hey guys, now you have to respond within 15 minutes. Go there. So and all this cycle can probably happen within a minute, because you're enhancing the capability of a satellite to process and do stuff on board in space, and then directly send it to the user.
So beautiful. So can we call this intelligence on the fly?
Yeah, you could call that intelligence on the fly. Yeah. Yes.
Okay, fantastic. So, Sethu, this brings me to the next part of this interview, that is your association with WGIC. So, I want to understand what brings ReOrbit to WGIC, and how are the business aspirations of ReOrbit aligning with those of WGIC and its members?
Yeah. So firstly, WGIC is undoubtedly the biggest, let's say, industry body when it comes to geospatial information. So definitely, being a part of that, one helps us on two ways, right? Like one, of course, we could market our products and get those connections, but also we could learn a lot from the industry trends as well, because at the end of the day, we at ReOrbit believe that, the only way to give the most efficient solution to the users is to not understand our users, but also to understand our users and their users. So as low we can get in terms of understanding the requirements on the value chain, the better we could actually design our solutions to our direct users. So and that's I think the beauty of WGIC. Sorry, yes, yeah. That way you have, like, you don't just have users, or you don't have let's say companies that are on a particular segmentation, but you have it along all the segmentation. So that helps us to understand the value chain as a holistic way.
Okay, thank you so much for enumerating that. And we also see that WGIC is a melting pot of geospatial companies from across the world. Some bring data, some bring products, some bring services and solutions. What role do you see for ReOrbit, and how do you intend to leverage these individual strengths of WIC member companies?
At the end of the day, what we are trying to do is to give the end user the most efficient solution, right? Like in the defense case, like the Coast Guard should react very fast. That's their ultimate aim. And to do that, it cannot be done by one company or one particular product or a service. So you need to sort of bring those forces together so that you could basically get the best platform, you could get the best services and the best data processing and so on and so forth. So that's where I see that we could basically join forces through this forum, given you have multiple layers of players here, and particularly where we fit is we are purely a space infrastructure provider. So we today provide state-of-the-art space infrastructure when it comes to the satellites. But that being said, we are already a partner with SatSure and Keledio EO, which is a part of SatSure. So we are now having a product offering, which is Glue on EO, as you rightly mentioned, which addresses end-to-end the optical, optical imaging, but also the data processing and data intelligence to the end user. So this is a product that sort of came out of all the discussions that we've been having with different companies within the WGIC. So I foresee that going forward, we could multiply on similar kind of products, where at the end of the day, all the members who are within your forum aims to give the best solution to their users, and that can only be done by joining forces.
Thank you so much. That's exactly the mission with which we are working together. And in fact, this conversation is also to help take your product and your offerings to the larger WGIC members and also the wider industry as well. Thank you so much for this time and this conversation. It is lovely knowing about ReOrbit and your journey with ReOrbit. Thank you so much, Sethu.
Thank you, Bhanu, for inviting me, and a pleasure talking to you.
Thank you.